So what are the steps in using Kmap to simplify our Boolean equation? So first step, select the respective Kmap based on the number of variables. Determine the number of variables to determine the number of size. Then second, determine what is needed. What is asked? Are you going to get the sum of term or product of term? What is given? So you need to know so that we could easily plot the output in our matrix. Okay. And then after plotting all the min term and max term or sum term or product term in our Kernel map, we're going to group it. If we're going to get the SOP, we're going to group the output of 1. If we're going to get the POS, we're going to group the output of 0. So how we're going to group it? All adjacent ones will be grouped. Okay, all adjacent 0 will be grouped, and one group will be equivalent to one term in our simplified equation. Okay, so how we're going to determine the size of the grouping? We still follow the power of 2 rule. Group of 1, group of 2, group of 4, and group of 8, and group of 16. Okay? And we need to have a square shape when we are grouping, or a rectangle shape. Okay? So that we know if the grouping is correct. Okay, again, power of 2 rule, and the shape of our group should be a square or a rectangle. Then afterwards, we're going to determine which among the group is the essential prime implicant. Essential prime implicant is basically the group that doesn't have a that doesn't have a shared in min term or max term, or there is an exclusive min term or max term on that group to be considered as essential prime implicant. On the succeeding slide, I'm going to show you what is an essential prime. Okay? And when you are writing the grouping, the prime implicant and essential prime implicant, so you need to note down everything so that later you know which essential prime implicant, okay, will be included on your final answer. Okay, so for example, we have function at AB is equal to AB naught plus AB plus A naught B naught. So we're going to follow this order, A, B. So it means for me, I'm going to use A for my row, B for my column. Okay, so how many inputs? 2. So therefore, our matrix will be 2 by 2 Kmap. So let's draw. So A will be for my row, B will be for my column. 0 for the first row, second row 1, 0, 1, a 0 for the first column, and 1 for the second column. So A, B naught. So just a review about A, B naught. What's the input of A, B naught if it's a product term? It's 1, 0. Don't forget, in the product term, the negated variable is equivalent to 0 input. Non-negated variable equivalent to 1 input. Okay, so it means AB naught is 1, 0. Okay, and for AB, it's 1, 1. So this is the square wherein we're going to put AB. And A naught, B naught, it's 0, 0. Again, why 1? Because product term, the intended output of product term is 1. So that's why we are writing 1 on the boxes. Okay? For AB naught, AB, A naught, B naught, the output is 1. Okay? But how about this box, unfilled box? It means the output is 0. But since we are looking for the simplified SOP, we're not going to plot 0 in our matrix. Okay, only the output of 1. Okay, when we, now we are ready for the grouping. So power of 2 rule, adjusted mean term, square or rectangle, start with the biggest group until all mean term has a group or max term has a group. Okay, always start with the biggest group. So power of 2 rule, 1, 2, 4. In a 2 by 2, the maximum group is 4, followed by 2 and 1. Okay, so since it is impossible to have a group of 4, so the next biggest group is 2. So we could group this mean term as one group and another group for this set of mean term. Okay, since all mean term has a group, now let's proceed with the next step. We're going to check if all groups are essential. If say essential, at least one mean term or max term is exclusive on that group. So in this group, do we have an exclusive mean term? Yes, this mean term is not shared on the second group. How about the second group? Does it have a exclusive mean term? Yes, we have this mean term or 1 exclusive to that group. So therefore, this is also considered as essential implicant. So we have 2 essential prime implicant, 1 and 2. So after determining the essential prime implicant, now we are ready to get the equivalent of that each group, okay? The product term for each group. So how do we determine the product term of each group? We're going to inspect the value of each variable, okay? If the variable change within that group, the value of the variable change within the group, that variable will not be part of the final term for that group. If the value of that variable is constant, didn't change within the group, it will be part of the term that will represent that group. So for example, A, within this group, what is the value of A? From this box to this box, it changed from 0 to 1. So therefore, A is not part of, okay, not part of the equation. Okay, how about B? B is 0, 0 within the group. So therefore, B will be part of the equation that will represent this group. So what is the value of B? It's 0. So therefore, when we get the product term, we just negate B. So we have B naught. So B naught will represent this group. How about this group? A didn't change from the first column going to the second column. So A will be part of the term that will represent this group. How about B? Did it change? Yes, from 0 to 1 in this group. So therefore, B is not part of the term. So since the value of A is 1, so the equation for this is just A. Okay? So when we get the SOP, just add these two or these two group. The final answer is A or B naught.